Hey guys, Darren here with Renaissance Coders, and today we're going to be continuing our camera controller series with the RTS camera. Let's go ahead and take a look at this camera to see what's going to be involved with getting it set up. Okay, so I'm going to switch over to my RTS camera here. As you can see, we don't need a target to operate this camera. Okay, now notice whenever I go over the hilly terrain that my camera adjusts its distance from the ground based on the height of the terrain. Okay, so what we're doing here is we're just making sure that the camera isn't going through the terrain, and this is our way of solving for that issue. So as we move our camera around, we're just ensuring that we're not going to be passing through the terrain, so we're maintaining the height based on the terrain's height. Now we also have the ability to rotate our camera around like this. Okay, so as you can see, we can rotate, and no matter which direction we're rotated, we're going to be moving. We're going to be able to pan back and forth and side to side and up and down based on our current camera's rotation. Okay, so this is what we have in store for this series. It's going to be a two-part series, and in this tutorial we're going to create our script. We're going to define what's going to be required, what methods we need, and we're going to also declare some settings. So let's go ahead and start by creating the script. I'm going to go ahead and delete the one that I have now, and I'm going to start over from scratch. So I'm going to right click in the control or the project panel, go to create, and then come up here to C# script. I'm going to name this RTS camera. Okay, so let's go ahead and open it. This is going to take a second. Alright, so here we have our fresh RTS camera script. Alright, now as I really like to do with a lot of these camera scripts is I like to define some classes that are going to be encompassing the settings required for the camera. Alright, now the first thing I want to do is define a layer mask for our ground. As you remember, whenever we move the camera around, it adjusts its distance from the ground based on the height of the terrain. Okay, so what we need is to know what the ground is so we can base our distance calculation off of the ground. So we're going to have a public layer mask called ground layer. Alright, now at this point I want to go ahead and define some classes that's going to be containing the rest of our settings. So these classes are going to be our position settings. So let's say public class position settings. I'm going to go ahead and just copy and paste this a couple more times so I don't have to rewrite redundant code. Alright, so we're going to have three classes. The second one is going to be our orbit settings. So it's going to be what handles the settings for turning or rotating our camera around. And then this last one is going to be our input settings. So we want the user to be able to modify the inputs for zooming, turning, and panning. We want them to be able to modify those input variables at runtime so that they can so at runtime they can determine what the best inputs are going to be. So that's more of a convenience class. Alright, so let's go ahead and define what we're going to have inside our position settings. We have quite a few variables here. We're going to have a public bool called invert pan, and I'm going to set that to true. Now what this invert pan is going to do is whenever we're clicking and holding down our mouse button to pan our camera back and forth or up and down, what's going to happen initially is our camera is going to follow the direction of our mouse. But if we have this boolean set to true, it'll feel a little bit more natural, at least for me anyway. So if I drag my mouse to the right, it's going to move the screen. It's going to pan left. So that's going to be a setting that some people are going to want and some people aren't. So we'll go ahead and include that. Let's have a public float for pan smooth. So this is going to be how fast we actually perform our panning calculations. I'm going to set this to 7. We're going to have a public float distance from ground. So this is going to be how far up in the sky we're going to be at any time, no matter what the terrain is. We're going to have a public bool called allow zoom. So do we want the user to be able to zoom in with the camera? I'm going to initialize that to true. And then we're going to have some more zooming settings here. So float, zoom smooth, we're going to set that to 5. Zoom step, so how far each time we activate our zoom input do we want to zoom in? So this is going to be set to 5 as well. max zoom, and the values that I'm setting to these variables are just values that I found worked well for me. You'll be able to modify these values based on the type of camera or the way you want your camera to interact with the scene. Okay, so then we're going to have a max and a min zoom, which is going to define the threshold that our camera can zoom in and out within. Okay, and this max zoom is going to be 25, and then we're going to have our min zoom, and we're going to set this to 80. Alright, and then we're going to have this hide in inspector value, because we don't care about seeing this value from the inspector, and we're going to set this to, we're going to call this new distance. We're going to set it equal to 40. And the purpose of new distance is whenever we're zooming and we want to zoom smooth, so if we're smoothing our zoom, we want to set a pre-calculated distance that we can move to. So whatever this new distance gets set to is going to be what distance from ground actually lerps to. Okay, so let's come down to orbit settings, and we're going to call a few of these. So we're going to have X rotation, public float, X rotation. We're going to initialize this to 50. This is going to angle our camera downward onto the map, and we're going to have a public float, Y rotation. We're going to initialize this to 0. Now the Y rotation is going to be what gets modified whenever we want to rotate our camera around to get a full 360 view of our scene. We're going to have a public bool called allow Y orbit. I'm going to initialize this to true. Now this is going to be what determines if we want our RTS camera to even be able to modify its Y rotation. A lot of RTS games have static rotation, so you won't be able to actually see the full 360 view of your scene, but I'm going to give that option here. Then we're going to have a public float for Y orbit smooth. I'm going to set this to 0.5f. This is, as you might expect, how fast we're going to be able to rotate whenever we're modifying our Y rotation. Okay, now our input settings, we're going to have 3 strings. So we're going to have a string for our pan. We're going to call this pan. Set it equal to mouse pan. Now if you've seen these videos, if you've seen some of my previous camera controller videos, then you know what I'm doing here. I'm setting these string values, for those of you who don't know what I'm doing, I'm setting these string values to custom input manager settings. Okay, so I'll go ahead and show you, if you don't know already, how to set your own custom inputs. If you already know how to do that, then just skip ahead a minute or so whenever I get to that point. We're going to have a public string for orbit Y. So this is going to be what determines how we are going to be rotating our camera. I'm going to call this mouse turn. That's an input that I've already defined. And then we're going to have a string called zoom, which is going to be set to the default input mouse scroll wheel. Okay, so real quick, if you don't know how to set your own inputs, I want to go ahead and cover that. So here you can see I set pan to mouse pan. Okay, so pay attention to this string right here. Let's go back to Unity really quickly. If I go to edit, I go to project settings and input, we can come over here and you'll have these axes right here. Now if you want to add an input, you'll just increment this size by however many inputs you want to add. Now remember, I had the mouse pan and mouse turn, so here they are right here. So by setting that string to mouse pan, it's going to be looking for this input that I've defined to be mouse 0, which is left click. Okay, so you'll see how we're going to be using that in just a moment. Okay, so we have, or actually you'll see how we use that in the next tutorial, sorry. Okay, so we have our classes and our settings defined. Let's go ahead and define some private members. Actually, the first thing we need to do, since we're going to be wanting to access these classes from the inspector to modify these values, we need to make sure we have public references to the classes. So we're going to have a public position settings called position equal new position settings. Same thing for our orbit settings, call this orbit equals new orbit settings. And then finally for our input settings, we'll call this input and set it equal to new input settings. Alright, now some private members that we need are going to be vector3 destination. And this destination is going to be where our camera is trying to move to. I'm going to set this to vector3.0. So the destination is going to be our vector3 position in space where our camera needs to move to. So if we have any sort of lerping, which we may if we enable that setting. Okay, so then we'll have a vector3 for camvel. So how fast do we want to move to our destination, vector3? This is going to be initialized to vector3.0. Then we're going to have public vector3. I'm sorry, not public. This will just be a regular vector3, and it's going to be previous mouse pause equal to vector3.0, and then a current mouse pause. Now we're going to be using the previous and current mouse position vector3s to handle our current mouse position whenever we're holding an input to either pan or turn. Okay, so whenever we're clicking and we're moving our mouse position, these two variables are going to be determine how fast we're going to be panning or rotating. And we'll talk about how to use those in the next tutorial. Then we're going to have some floats to hold our input values. So float for pan input, orbit input, and zoom inputs. And then we're going to have a pan direction. So which direction do we want to pan in? We're going to call this pan direction. And what's going to happen is if our invert pan is set to true, then we're going to be modifying this pan direction and multiplying it by the speed that we're going to be moving panning our camera in. Okay, so we'll talk about how to use that in the next tutorial as well. Okay, so we have all of our settings laid out for this class, and by now you guys should be able to see what it is that we're going to be doing with these settings, and we'll be talking about that more in the next tutorial. But let's go ahead and define the classes that we're going to be using, or not the classes, the methods that we're going to be utilizing these settings in. Okay, so first of all, we're going to have our start event function, and this is going to be the purpose of this is going to be for any initialization code that we might require from our camera. Then we're going to be having our get input. So get input is going to be our next method, and this is going to be responsible. Okay, so let me go ahead and add comments here. So start initialization code. Our get input is going to be responsible for setting our input variables. So that's going to be our pan input, orbit input, and zoom input. Then we're going to be using our update event function and our fixed update event function. Okay, now update is going to be responsible for updating our input. It's going to be responsible for zooming, and it'll be responsible for rotating. Basically, almost everything is going to be going into update, and it'll be responsible for panning. Okay, now fixed update is going to be handling our camera distance. So handle camera distance, and the reason this goes in fixed update is because the way we're going to be handling our camera distance, remember if you recall from the beginning of this video, our camera was able to adjust its height based on the terrain that it was looking at. Okay, so whenever we handle our camera distance, we're going to be using raycasting to the ground, and anytime you use raycasting, you'll want to put that in fixed update. Okay, our next function is going to be pan world, and I'm not going to put any comments there because that's self-explanatory. We're going to be handling how we're going to pan our camera left and right and up and down in the world. And then we're going to have our void handle camera distance. These methods are all pretty much self-explanatory just based on the names. We're going to have a method for zoom. And then we're going to have finally our method for rotating. Alright, and that is going to wrap things up with this tutorial. We defined all of our the entire skeleton of our RTS camera script. We finished up defining our classes and settings, and now in the next tutorial we're going to be discussing how we're going to be utilizing these settings to pull off each one of these functions. Alright, until then, I'll see you guys in the next tutorial. Thanks for watching, and have a great day.